So, some final thoughts here in the preparation for your review here. Let's just take a look at all these here. At the basis of everything that we're doing here is being able to check to see whether a solution, proposed solution, actually solves the system. So when you're looking at this here, first move is understand that this here is an X, this here is a Y. So everywhere you see an X and everywhere you see a Y, you can substitute those in there to see if it's the solution or not. So looking at the top one, we're just doing -5. X is -2 plus 5 times 2. We are checking to see if it's 10. Take it one step at a time. -5 times -2, that is a positive 10. 5 times 2, that is 10. Is 10 plus 10 equal to 10? No, it is not, right? We have 20, which is not equal to 10. So it did not work with the first one. There is no point for checking the other one. Why not? In order for this to be a solution to the system, it needs to work for both. If it didn't work for the first one, what's the point? Okay? Looking at this one here, if we were to do the exact same thing, check if 4, 3, there's your X, there's your Y, check to see if that's a solution. 3 times 4 minus 3 times -3, and we're checking to see if that's 21. 3 times 4 is 12, minus 3 times 3, well, a -3 and a -3, why don't we just call that a positive 9? Is that going to be 21? 12 plus 9 is 21. So yes, it worked for the first one. Now let's see if it works for the second one. We have 2 times, put the X in there, which was 4, 2 times 4, minus a -3. Remember, why are we going forward with this? Because it worked with the first, now we need to check to make sure it works with the second one. 11, so 2 times 4, that's 8. A minus and a minus combined together to make it +3. So is 8 plus 3, 11? Yes, it is. So it worked for this one too. So is this a solution? Yes, it is. So don't forget this part. You know, I kind of forgot that when we finish this up here. That's a yes. This one here, because it didn't work for the first one, that is a no. Question 2, looking very, very closely here to see why graphing would not be a good strategy here. It's not in slope-intercept form. Substitution would be a great strategy here because we have the y by itself. So if y is equal to this, then we plug that in there for that y right down there. So then our next move of substitution is rewrite it. 28x plus the 4, which is still there, and then -7x plus 13. What we're doing is we're just substituting in this quantity in here for y. The 1-2 punch. Distributive property. Punch number 2, combining the like terms. What do you notice here? That's going to make 0x, and we know that 0 times anything is just 0. So we have 0 here, 52 is all that's left, equals -12. So if all this turned out to be just this, which are clearly two numbers that aren't equal to each other, then we have no solution. Number 3, solve this one, graphing. Y equals, nope. Here, substitution, variable by itself, nope. Elimination, do we have elimination? We need same variables, that's 1, that's 3, no. No. 1, no. So this will happen. And when this happens, you need to figure out what's going to be the best course of action to improvise here. Let me show you one particular way that actually wouldn't have been that bad. Elimination could work here. Elimination could work because all I'd have to do with this top equation, if I multiplied everything by 3, making that 3x, y times 3 is 3y, 5 times 3 is 15. Now, because I have the same variables dictate that I subtract in order to get these to eliminate. And be careful, we got to focus on that subtraction sign. Subtraction can be a little bit problematic for some students, so make sure you're being very, very careful. This is an expert move here. Is 3x minus 3x, that's 0, which accomplishes what we want with elimination. Notice here we have 3y minus a minus 5y. Subtracting a negative is the same as adding it. So minus that, we're going to add 5 to that 3 to give us 8y. Same thing's going to happen here. 15 minus a negative 1 is like saying 15 plus 1. So we have 16 there. Final move here, dividing both sides by 8, y was 2. Next move here, looking at your original problem, which was just this. Now I can take that 2, substitute it in here, and then solve for x. So if x plus 2 equals 5, then x needs to be, when we subtract 2, 3. Next one here, graphing. Y equals. Yes, let's graph this one. Graphing, slope-intercept form, right? When you have an equation that's in this form here, y equals mx plus b, the first thing that you need to start with here is you always start with this number, and it goes on that y-axis here. So in this case we have a 6, which goes right there. Now the slope, because that's negative 1 over a positive 1, our pattern here to create more points is going down 1 and to the right 1. When you run out of room, reverse it. You can make the line or don't make the line. It really doesn't make a difference. All we're interested in is where do these patterns cross. So slope-intercept form again here. So we start at 3, negative 3, right down there, right? Because that negative 3 there. Now this pattern starts to go up 2 and to the right 1. Boom, there's the intersection point right there. Just by continuing this pattern, we now have our solution right there. So now all it's a matter of is writing down the address of that solution. We went 3 to the right and we went 3 up to get there. So our answer here, 3, 3. You can write it like that, or you can just write it like we were writing the other ones here. You can say x equals 3 and y equals 3. I don't care which way you write it. They're both saying the same thing. Okay, this one here, graphing, y by itself? Nope. Substitution, y variable by itself? Nope. Elimination, do we have opposite or same? Yes, we do. Look at that. We have the x's here. 2x, negative 2x. Those are the opposite. Opposite we always add. If it were the same, same we always subtract. But since we have opposite, we're going to add these up. So adding these together, negative 2x plus negative 2x makes 0, is what we want to eliminate. Negative 14 plus 3. That's going to be a negative 11. A negative 11y. Next, negative 8 plus a negative 14, I believe that's going to make a negative 22. So now our algebra to solve for y, if it's being multiplied by negative 11, we got to divide by a negative 11. So that leaves us with y being equal to a positive 2. Next move, take that 2, substitute it in for either one of these two y's, it does not matter which one, and then we solve it from there for x. So we have negative 2x plus 3, substitute the y value we just found there of 2, and that's equal to negative 14. Multiply. Solve for x. Let's subtract 6. So now negative 2x equals negative 20. Final move, divide by a negative 2. Cancels out. Negative 20 divided by negative 2. Negative divided by negative. We get positive 10. So which one variable did we just solve for here? Oh yeah, x. So x equals 10. Alright, so to recap here. Notice I just solved this one with elimination. Previously, solve with graphing. Previously, solved this one with substitution, and then before that we solved that with substitution. Notice substitution was used once, graphing was used once, elimination was used once. You will get a bonus point if you can do that for me on test day. Next, graphing inequalities. Got to graph the line here. Remember, this y-intercept number always goes on that y-axis here. So, positive 2, there we go. Slope, there's that negative 1 over 1 again. Until you run out of room, reverse it to get the other ones here. Okay? Now, unlike the graphing one we did earlier, when we're graphing inequalities, we got to remember where we're going to, what kind of a line we're going to have. What's that boundary line going to be? So to remember that, to do that, you got to remember that when we are graphing solid lines versus dashed lines, what is true about the inequalities? For solid lines, this is when we're less than, equal to, or greater than or equal to. With dashed lines, we don't want to include that line, so we want less than or greater than. If we have any one of these two, we're going to make a dashed line. If it's equal to, notice a solid line underneath, we're going to put a solid line there. So what do you notice about these two? Neither one of them. I mean, they're both these here. So we're going to make dashed lines all the way here. So let's make this one here a dashed line. There we go. We're going to adjust that line here a little bit. Perfect. Now the next part, shading above the line or below the line. One other distinction we can make here is if it's less than or equal to, we are always going to shade below the line. Greater than and greater than or equal to, we are always going to shade above the line. So according to this, notice the 2 right here. Notice all these ones here, because this is less than, we want to shade below the line. All these values here are below. So that means that below the line is everything that is right down here. So I'm going to shade this as lightly as I can. Okay? If I lived here, this line's happy. Now what about the other line? Y is greater than negative 1. When you're missing that x right there, we are going to have a horizontal line at negative 1. Missed there again. Bring it up a little notch. There we go. And because it's greater than, we want to shade above. So if I shade everything above here, I have everything up here. So in other words, if I lived in any of this area, I'd make that red line happy. The key to making now Mr. Cook happy is I want you to shade or figure out the spot where a point could live that would make both the red line and the blue line happy. It's that purple area in there, isn't it? This spot right there. Make this dark, 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 dark. As dark as you can. Okay? I need to make sure, you need to do whatever you can to make sure that I know that is the solution area. Okay? Let's do one more. 3 inequalities to make here. The first one looks pretty familiar. I think that's a horizontal line again. Why? Because x is missing. Go to 4. Which way are we shading here? We're shading below the line because that's less than, or wait a second, see my mistake here? See how it's equal to? See the solid line? Solid line underneath. So our line needs to be solid. In fact, if you go look ahead, all these lines are going to be solid, aren't they? Now, shading. Less than or equal to. Shade below. Okay, that guy's happy. The middle one, -3. Start down here. Slope is 2 over 1. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Out of room, reverse it. Solid line right there. What area do I need to shade to make this guy happy? That is greater than or equal to. So we shade above that line, which is everything on this side. Okay? Try this again. A little bit off there. There we go. Next, this one here. Start at that minus, hey, it's the same spot. Slope, put that negative sign up there with the 1. So now we have down 1 and to the right 2. Down 1 to the right 2, new spot. Down 1 to the right 2, ran out of room. See the pattern? Reverse it. Up 1 to the left 2. Up 1 to the left 2. Ran out of room that way. Let's put in our line. Solid line again. Which area do we need to shade to make this guy happy? Less than or equal to. Less than. See how these ones here are less? These ones up here are more than that y-intercept number. So this is the side that we shade. Now where's the area that I need to live to make all these guys happy? Making all these guys happy would be this spot right in here. So let's make this a little bit darker. That's better. That's our solution area. Back over here, the spot that makes everybody here happy, that spot right in there. Okay? So keep studying. Best of luck. We'll see you tomorrow.